Okay, today's topic is the Pythagorean theorem. And Pythagorean was a Greek guy who came up with this theorem that we're going to talk about today. And the Pythagorean theorem is used for finding the missing side length, of a right triangle. And you can use a right triangle in many, many real life situations, and we are going to discuss those. Like, for instance, when you have a baseball field and you need to know the distance, that you need to measure off the distance. Well, guess what? You know that baseball field is kind of shaped like this, isn't it? And so to find the distance between the bases, you can make it a right triangle. I know that doesn't look very good, and you can find the missing side length to your right triangle. And believe me, a baseball field out there is a right triangle. You will use this a lot. It is on your formula chart. Right down here it says Pythagorean theorem, a squared plus b squared is equal to c squared. Okay, so you will be using your formula chart. Pythagorean, like I said, was a Greek guy. All right, we are going to, these are the sides of our right triangle. We are going to label them. You always have a right angle on a right triangle, and the right angle connects the two legs of a right triangle, and we call those legs A and B. So I'm going to say A leg, B leg. Those are interchangeable. It doesn't matter if you call this one B and this one A, or this one A or this one B. Okay? We take the point of that right triangle and draw across from it, and this diagonal side is known as the hypotenuse. I know that's a crazy word, hypotenuse. And we say that that is C. And remember, I showed you on your mathematics chart that a squared, which is right down here, plus b squared is equal to c squared. And we're going to prove that right now. Okay? So let's look. This is A. Okay? And this is B because I draw my arrow. That means that this is C. Okay? They're saying that this right triangle inside, that A is this side length and B is this side length. And I am going to do this. I have the side length is 3. So we've already discussed 3 times 3 on a square is the same as saying 3 squared. So the whole thing is 3 squared, which is 9, isn't it? And I'm going to go ahead and color, and you guys don't need to do this, but you could also do something. I want to show you how this works, and I'm going to do that by colors, but I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 units squared, okay? So then we have this side length, which is 4. And remember that this says that this is 4, this is 4. So the area, or the part inside the square, is going to be 4 squared, which if you put 4 squared in your calculator, it's not 4 times 2, it's 4 times 4, which is 16. And I'm going to go ahead and do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I'm kind of going a little bit fast, I know, but this is an important topic, but also I don't want to make this video too long, and we have a tendency to do that when we're talking about Pythagorean theorem. So I'm going to color that part of it blue. So remember, the theorem states that if you take the square of this leg plus the square of this leg will equal the square of the hypotenuse, or C. So let's see if that's true. If I have 9 here, let's say I color 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would color everything red that is in here, wouldn't I? Okay. Then here, that's this squared. So this would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then this is 16, so I'd have 16 more. 1, and then this is 1, 2, 3, 4, 5, and 5 times 3 is 15, plus 1 is going to be 16. So the rest would be taken up by the area of this side, okay? And if you notice, we filled the whole thing in. Well, let's think about this. 5 squared is equal to what? If I put 5 squared in my calculator, you get 25. Well, that makes sense because 9 plus 16 is equal to 25. If you put that in your calculator, 9 plus 16, you get 25. So we've just proven his theorem correctly, that a squared, the side length squared, plus this side length squared is equal to the longest side length squared. So the theorem only works on right triangles. It doesn't work on equilateral triangles, okay? It has to be a right triangle, and in order for you to know that it's a right triangle, you will need to find that right angle. Okay, so here's how to solve using the formula. First, you're going to write it down. That's going to be step 1. We are going to insist you do that. Second, you are going to write your side lengths down. 3 squared plus 4 squared equals 5 squared. So then 3 squared in my calculator is equal to 9, plus 4 squared in my calculator is equal to 16, and 5 squared is equal to 25. Okay, so let's see, what is 9 plus 16? It does equal 25. So 25 is equal to 25. Therefore, this is how we have proven that it does work. What if you don't know what the side of the hypotenuse is? What if they just give you A and B? What would we do to solve that? Well, if A is 4, we would put here on this line 4 squared plus B is 11 squared is equal to C squared. So it's not just the side length C, it's C squared, which is the area of the square that we can draw off the side. Okay? So 4 squared, if I put it in my calculator, is 16. And I'm going to teach you a shortcut, but not today. Every step must be written down. If I don't see your steps written down, you will not get credit. Okay? Plus 11 squared is 121 is equal to C squared, because we still don't know what C squared is. Then you're going to add these two, 16 plus 121, and you're going to find out that that's 137 is equal to C squared. Now, we just did it yesterday. How do you undo a square? Because we don't want to know what C squared is. We want to know what the side length is of the hypotenuse of C. This hypotenuse, we want to know what the side length is of this square. So, we are going to take the square root to break it apart. What we do on one side of an equation, we must do on the other side of the equation to keep everything equal. So C squared, it becomes C. And in our calculator, we can put second square root, 137, arrow out, remember, and hit enter. And I am going to put, it is approximately 11.7. I'm going to round this number to the nearest tenth. Okay? So here's what each letter represents. A represents a leg. B always represents a leg. So these are interchangeable. I don't care which one you call A. I don't care which one you call B. Okay? C is the only thing that always has to be the hypotenuse. And remember that that hypotenuse is the diagonal side, okay? And so that is the side that is the longest and is across from your right angle, all right? So on the back, I kind of have some information for you, and it talks about the Pythagorean theorem, and it says the area of this plus the area of this equals the area of C. Okay? So you could write this, the area of B or A plus the area of C is is equal to the area of C. Remember, the area of a square is side squared. That's why we are taking the square root. Okay? You undo a square by finding the square root. And I've given you a nice picture and drawn your right triangle right here. Okay? All right, for today, that's enough information. All right? I want you on your triangles for your practice today. You need to make sure that you are drawing that arrow across, because C, I want you to show me where C is. You are going to have steps today, and your first step, your quick practice is going to be real easy. You're going to write down the formula. I don't care. I know no, you're going to write down the formula. You're going to write the steps just like this. So we have one step. This will be one step. This is 2 steps. This is 3 steps, 4 steps, 5 steps. I need all 5 things written down on your quick practice today. You have a very short quick practice, so please do it and make your time wisely, and then you will have a quizzes to do for finding C. Okay?